Let's break down this question. So here we have x squared plus 1 over x squared minus 4. So our goal here is to basically determine the coordinates of a turning point. So a turning point, in other terms, we're trying to determine the stationary points, okay? We're trying to determine the case where the derivative is equal to 0, dy dx is equal to 0. So the first step, therefore, is going to involve us determining the derivative of this very equation. So let's call the numerator our u, denominator our v. So we understand our formula is going to be v multiplied by u prime minus u v prime over v squared. Now if we're going to say our u is the top part, then it implies our u prime is going to be 2x. If we're going to say our v is the denominator, then we understand as well that in that case it's going to be 2x as well. You understand how to differentiate, right? The constants are going to be eliminated and the common part is x squared, so therefore that's what we have. Now for the very first part, let's now substitute in the function to determine the equation to determine the derivative. So our v is the first part, so our v is x squared minus 4 multiplied by our u prime, which is 2x, as good as putting it in front, okay, which I believe is better. And then as well for the other part, minus u v prime. So our u is this part multiplied by v prime, so I can start with a v prime 2x and then x squared plus 1 divided by v squared, which is x squared minus 4 squared. Okay, so that's what we have. Can we simplify this to make our things easier? Of course we can. Let's try it out. So go on and distribute whatever we have there. So we're going to have 2x to the power 3 minus 8x. Then for the other part, that will be minus 2x cubed as well, and then that will be minus 2x over x squared minus 4 raised to the power 2 in brackets. Can we go beyond this point? Of course we can. So let's try to see what we have. This part and that part can subtract. You remain with negative 10x over x squared minus 4 to the power 2. So therefore, the y prime we have is negative 10x over x squared minus 4 raised to the power 2. Now at the point where we've reached, our goal is to determine the point where the derivative is going to be equal to 0, meaning that we equate whatever we have to 0. Can we find the values of x? So this is our y prime, don't forget that, which is our dy dx, right? So therefore, if we're going to equate what we have, negative 10x over x squared minus 4 squared to be equal to 0. In this case, for that to be true, it means the numerator is supposed to be equal to 0. So therefore, the possible values is our x being equal to 0. Right? Simple and straightforward. Is there any other way in this question that we can get a derivative of a 0? Well, as things stand for now, I don't think so. I don't think there's any way. Okay. So therefore, our x being equal to a 0, to find the other turning point, you're supposed to substitute in the to find the y value. Sorry, supposed to substitute in the equation itself. So our equation itself is x squared plus 1 over x squared minus 4. Right? Take note of that. So that being the case, if you plug in 0, 0, you remain with 1 over -4. So we have 0, -1 over 4. Right? That's one thing that you need to take note of. So this is our turning point. That is our turning point. Now, moving our attention to the other part of the question, which is dealing with determining the asymptotes. I did already explain certain facts to you that when you're dealing with the asymptotes, for the vertical asymptote, which is the simplest, it's basically the point where the denominator is equal to 0. So in this case, we have x squared minus 4 being equal to 0. So x squared being equal to 4. Find the square root of 4 both sides, so it's going to be plus or minus 2. So vertical asymptotes are negative 2 and positive 2. So those are the points where the curve can't cut in terms of x values. Then for the horizontal asymptote, we said it is based on the fractions you have. If you check the ones we have in this case, look at the highest degree, it's the same, right? So when it's the same, we said it's their coefficients. So we have 1 and 1. So 1 over 1 is just going to give us what? A 1. So therefore, y is equal to 1 is the horizontal asymptote. The other thing we said was when the denominator is heavier, that means if we had the power of 3, for example, the denominator, in such a case, it's basically a different case. In this case, y is equal to 0 is taken to be what? Taken to be horizontal asymptote. In a case where it is the opposite, the power is higher on top, in such a case we said what you have instead is an oblique. So you divide by long division or synthetic division to get the equation of the oblique asymptote or the slant asymptote. So these are the equations of the asymptotes in this question.